All right, good morning. Yes, my name is Ben Taylor, and I'm a performance engineer providing consulting services through my company, Taylor Data Consulting. And I am the creator and maintainer of pvcaptest. So what is pvcaptest? It is a Python package for running capacity tests per the ASTM standard. It's got some flexibility, so sometimes there's capacity tests with different regression equations. So it's built to be a flexible tool. It's an MIT licensed open source software. It's available on GitHub. It was first introduced at this workshop back in 2019. And I've been working on it for maybe 2 years already at that point. There's documentation available and read the docs. So if you Google pvcaptest, that should come up pretty quickly. And it's available to install through Conda or pip. And most importantly, what is the goal of the project is ultimately, I don't think we've gotten to this point yet, but it's open source very intentionally so that when there's multiple parties that need to run a capacity test, like a owner, a EPC, and an independent engineer, the real long-term goal would that be that those parties could use the same tool. They could open source tool, they could potentially all contribute and agree that this tool works, and then run their own test to validate and compare the results. So I'll give you a little bit of background on how the capacity test actually works before getting into the updates of the package itself. So the ASTM test is a regression-based test to assess the performance of the plant. So that's the standard regression equation. So you're looking at measured power, AC power, typically against plane of area radiance, ambient temperature, and wind speed. So the steps to get to the point where you're actually performing that regression is somebody's built a plant that's working and running and is commissioned, and you're able to get data from it. We had a great presentation about quality checking data, which is a good next step to do. At that point, you've got some data that you feel is reasonably good quality, could be in CSV or Excel formats, and you need to get that into a data processing tool to do the next filtering steps. That could be Excel, R, or a Python tool like Pandas or pvcaptest written in Python. To organize that data, visualize it, usually it's a good thing to look at the data that you've got. The heart of the capacity testing is these filtering steps. And when you're finished filtering, you typically calculate reporting conditions from that filtered data to come up with a set of values for those weather station measurements that are representative of the test period for that you're running the test over. And at that point, you can fit your regression. You get regression coefficients. You can plug those regression coefficients and your reporting conditions back into the equation to get a predicted power. So you do all that for your measured data from the plant itself. Do it all again for the data that's coming from your model, usually pvsyst. Compare those results. You might be required to calculate uncertainty of those results and then present that all. So pvcaptest is trying to help you do these steps 4 through 13. Doesn't include any data quality checks. More specifically, there's functions to load the data, and then those will give you back an instance of the cap data class, which contains methods for doing the filtering and visualization and fitting your regressions. So a quick visual version of that, you use those functions to load data. You get data in Pandas data frames. You can do your filtering and then visualize those. We'll talk about that graph a little bit more later. And then do that again, same process for the simulated data, and then make a comparison. So this is all showing the output of methods you can run. The top right there is a summary of the predicted power and comparisons of the predicted power. There's a little chart there. It's a little small to read, but it includes the regression coefficients and the p-values of those regression coefficients. And then if you took those two plots on the bottom to the left and middle, you turn off all the filtering until you get to your last data set that you fit the regression, you can compare those. That's what's shown on the bottom right there is comparison of those filtered data sets. So the focus of this will be on what's new in the pvcaptest package. I'll have a quick overview here. So we're at version 0.53 back in May of 2019. quite recently up to 0.11.2. And one thing to note is that since that time, the name of the package actually did change from captest to pvcaptest. There's actually quite a few things named captest out there, so to make it a little easier to find, they've changed that. The condo package is pvcaptest, so that should be easy to find. There's new documentation. There's a new user guide on the documentation. So there's change to the package structure. We had one module. There's now 5 modules. Loading data and column grouping are 2 things we'll focus on here. There's been some big changes on those to try to make it easier to use. There's some new filtering methods for new filtering methods. The reporting irradiance methodology or tool method has been refactored. There's new functionality for outputting a CSV file documenting the filtering steps that you've done, or providing to somebody reviewing so they can review exactly what's happened. There's new visualization methods, and then at the very end, there's a quick slide on work that's still ongoing. So for the user guide, this didn't exist before. There were examples, so that was a good way to look at what was going on. But there's now a user guide. It's structured and organized generally to follow the steps that you would follow to perform the capacity test, and it kind of complements the examples in providing a bit more explanation of how all the different functions and classes and methods would fit together, and how that's structured to be able to facilitate performing the test. You can run tests of plants with bifacial modules. The regression equation is quite easy to change, and so there's a new note on that kind of tells you how you would go about doing that to change the regression equation. And there's a new update to the installation section. So I was trying to make that easier to follow so you can actually get to using the project. So loading data to use pvcaptest, you got to get your data into it. So I'm trying to make that easier to do. Previously, you had to create an instance of cap data and then call the load data method on it. That's been reworked so that now you can just call the load data function and it will give you back your cap data object with data in it already loaded. And behind the scenes, there's a whole new module that is helping to provide that data loading functionality. And there's more flexibility there. So you can now do things like you can point to an individual file, you can point to a directory of files, you can give a list of files you want to load. There's a lot of flexibility there. The default is to load CSV files, but there's also the ability to load other file types if you have Excel data or data in other formats. And you can load data files that have different column headings. So if your power data is in one file and you have meteorological measurements in a different file, if you put those in the same directory, it will do its best to put those together for you and give that back to you. So column grouping is pretty important to the functionality. This is if you have a small project that only has one sensor of each type, one plane array sensor or one wind speed sensor, this is less important. But when you have a large project with multiple MET stations, you need to keep track of all the sensors that are making measurements of the same type and likely aggregate those. And that's all done based on having a grouping of the different columns of your data so it knows what's what. Previously, that was sort of hidden in the back of the package, and the algorithm that will group it has not changed, and there's so many different naming conventions for data that you don't always get what you want. So it's now much easier to specify that in an external file. So you can use Excel or JSON or YAML and specify the column groups. And there's a nice workflow now where you can load data and set the column groups template to true, and it'll give you an Excel file that looks like this, where column B will be all the column headings, column A is blank. You can fill in your grouping, your group IDs there, and they can just run it again and point to that file, and you'll get exactly what you want. So oftentimes that can be the easiest way to go about doing that. There's a few new filtering methods. There's a filter shade method that's specific to PVSys and was just broken out from a larger function. Filtering days is easier now. If you have a week of nice clear sky data and you have 2 days in the middle of that are cloudy and you just want to take those 2 days out instead of doing some other kind of filtering for clear versus cloudy weather, you can do that. You can do the reverse of that and keep just a set of days. There's a small new function for filtering power, which is often done to filter for clipping, and a method for filtering out rows where you have missing data, which is sometimes important. There's a filter outliers method that will not work if you have missing data. So it's the primary purpose of that. So for reporting irradiance, the default approach to calculating reporting irradiance is to follow the ASTM I think it's 29 one. And the default there is to calculate the 60th percentile for irradiance. So that's the default behavior. There's pretty common contract language that uses a different approach and tries to find a balance of the amount of data that you have above or below the irradiance value that you pick for your reporting irradiance. So that functionality has been refactored and I think is much improved, and you can get basically the small dashboard that's shown on the left there. And that's interactive, so you can adjust the percent band there, the top left toolbar that's shown there, and watch the plot change. And there's functionality to export that plot as an HTML file, which retains the interactivity of that plot, so you can zoom in that plot and hover on it. When you export it, you don't get the interactive toolbars that are on the left, but you get the HTML file. You can also export all the data to a CSV file that's behind those plots. So you can provide that to anybody auditing the test for them to review. Another tool for data auditing is to export documentation of all the filtering steps you've done. So you can send that to a CSV file. It has all of the rows of data that you started with, and there's a column for every filtering step you ran, and it will show you exactly which filtering step removed which row of data. And the column headings there all match with the other tools to document the test. So the top right there is a summary tool that's going to show you a summary of your filtering steps, how many points were there before and after, what arguments you had used. So the labels there will match the labels of that export file. The labels there also match the labels of the scatter plot you see there. So that's all linked up. You can look at that in all of those different formats to understand what you were doing or what somebody else was doing with regards to the filtering. So visualizations, we've seen that plot on the left there a few times. What that's showing is an overlay of plane of array versus power. And there's a legend entry there for every filter that you ran, and it's interactive. So if you click on that, it will hide the corresponding color so you can see which points in that chart were removed by which filter. And the right plot is the same concept, but it's a time series plot of power. So you can look at it in that manner as well. So what's ongoing currently? Hopefully adding some more approaches to filtering for clear versus cloudy skies. There's a existing method that is based on the PVLib algorithm for doing that, which is actually quite strict. So sometimes you don't want just perfectly clear data because you won't end up with enough data. So it's on the to-do list to add some more approaches to filtering for clear versus cloudy so that you can maybe retain some more marginal data. Those will just be sort of like rolling standard deviation or rolling percent change type functions. The examples page is a great way to get oriented to the project. And at the top of those examples on the documentation, there's a button to click that gets you a live version. It's not working right now, so that's high on the list to fix. Calculating uncertainty of the result is also ongoing and future work. So I think that's an important piece that would be very nice to have more accessible. It tends to be sometimes required and sometimes isn't required, and sometimes is a bit daunting to figure out really thoroughly. And so the goal there would to just have that be more accessible, so it's easier to quantify how certain we are about the result of the test. I'm hoping to add some new sections to the documentation site, like a contributing section. So if it's open source project, if you're interested in, you read the documentation and see issues and interested in changing that, then you're welcome to do so. And the contributing section would be a great place to start with that. So it's easier for other people to understand how to get involved. The current examples are using PVSys data that I've then sort of added a bit of noise to. And so the measured data side of it is not that realistic of what you might actually see. I think it would be great to use real data from a plant. If anybody out there is willing to share their data, I think that would be a big improvement there. And the API reference is just alphabetized. It's would be much better to have that organized, I think, by function. It'd be nice to update the doc style. It's starting to look a little outdated compared to some of the other open source projects out there. And hopefully some user issues. So anybody who's using it and sees places for improvements or runs into something that looks like a problem, we'll move those right to the top of the list to address. And so with that, I'll just leave this slide as the final slide here with places to get help or look at the package. So you can always contact me. If you go to the GitHub site, that's where the source code is. You can open an issue there. It's totally fine to open an issue that is just a question about how it works or something that can turn into an improvement to the documentation. It's quite likely somebody else has the same question. You can fork the code and feel free to do what you want with it. And the documentation is all available on Read the Docs, as I mentioned. So that's easy to find and provides a good introduction to the package. Thanks for your time.